Solve this radical equation, where x is a real number. A usual way to solve a radical equation like this is to remove the radical by squaring both sides of the equation. However, for the given equation, if we square the equation, the resulting equation is a quadratic equation. Solving a quadratic equation is not always easy. So, we will use the substitution method to solve this radical equation. Let y equal root of 14 minus 2x. Then y squared equals 14 minus 2x. We label it as equation 1. The original equation can be written as 2y equals 14 minus x squared. We label it as equation 2. Rearrange equation 1, we have 2x plus y squared equals 14. We label it as equation 3. Rearrange equation 2, we have x squared plus 2y equals 14. We label it as equation 4. From equations 3 and 4, we have 2x plus y squared equals x squared plus 2y. Rearrange the equation, we have x squared minus y squared minus 2x plus 2y equals 0. X squared minus y squared can be written as x minus y times x plus y. Negative 2x plus 2y can be written as negative 2 times x minus y. Now the two terms on the left-hand side of the equation have a common factor, x minus y. So they can be factored as x minus y times x plus y minus 2. Now, the equation has been transformed into a product of two algebraic expressions equals 0. So, each of them could be equal 0. Case 1, x minus y equals 0. Case 2, x plus y minus 2 equals 0. For case 1, we have y equals x. Substitute y equals x. In equation 1, we have x squared equals 14 minus 2x. Rearrange the equation, we have x squared plus 2x minus 14 equals 0. For case 2, we have y equals negative x plus 2. Substitute y equals negative x plus 2. In equation 2, we have 2 times negative x plus 2 equals 14 minus x squared. Rearrange the equation, we have x squared minus 2x minus 10 equals 0. For each case, we have a quadratic equation, which can be easily solved by using the quadratic formula. X equals negative b, plus or minus root of b squared minus 4ac over 2a. For case 1, a equals 1, b equals 2, and c equals negative 14. So, x equals negative 2, plus or minus root of 2 squared minus 4 times 1 times negative 14 over 2 times 1. 2 squared minus 4 times 1 times negative 14 is equal to 4 plus 56, which is 60. So, x equals negative 2, plus or minus root 60, over 2. 60 is equal to 4 times 15. So root 60 equals 2 root 15. So, x equals negative 1, plus or minus root 15. For case 2, a equals 1, b equals negative 2, and c equals negative 10. So x equals 2, plus or minus root of negative 2 all squared, minus 4 times 1, times negative 10, over 2 times 1. Negative 2 all squared, minus 4 times 1, times negative 10, is equal to 4 plus 40, which is 44. So, x equals 2 plus or minus root 44, over 2. 44 is equal to 4 times 11. So root 44 equals 2 root 11. So, x equals 1 plus or minus root 11. Next, we verify whether they are solutions of the original equation. Before doing this, we need to consider the domain restrictions imposed by the square root and the equation itself. The radicand 14 minus 2x must be greater than or equal to 0. So, x must be less than or equal to 7. As the left-hand side of the equation is non-negative. So the right-hand side of the equation, 14 minus x squared, must be greater than or equal to 0. That is, x must be greater than or equal to negative root 14, and must be less than or equal to root 14. Overall, x is greater than or equal to negative root 14, and is less than or equal to root 14. As negative 1 minus root 15 is less than negative root 14. So, x equals negative 1 minus root 15 cannot be a solution. That is, for case 1, only x equals negative 1 plus root 15 is a potential solution. Because 1 plus root 11 all squared is equal to 12 plus 2 root 11, which is greater than 14. So, 1 plus root 11 is greater than root 14. So, x equals 1 plus root 11 cannot be a solution. That is, for case 2, only x equals 1 minus root 11 is a potential solution. Now we verify whether they are solutions of the original equation. When x equals negative 1 plus root 15, the left-hand side of the equation is equal to 2 times root of 14 minus 2 times negative 1 plus root 15. The radicand can be simplified to 16 minus 2 root 15, which is equal to root 15 minus 1 all squared. So, the left-hand side of the equation is equal to 2 times root 15 minus 1. While the right-hand side of the equation is equal to 14 minus negative 1 plus root 15 all squared. Negative 1 plus root 15 all squared is equal to 16 minus 2 root 15. 14 minus 16 minus 2 root 15 is equal to 2 times root 15 minus 1. So, x equals negative 1 plus root 15 is a solution of the original equation. When x equals 1 minus root 11, the left-hand side of the equation is equal to 2 times root of 14 minus 2 times 1 minus root 11. The radicand can be simplified to 12 plus 2 root 11, which is equal to root 11 plus 1 all squared. So, the left-hand side of the equation is equal to 2 times root 11 plus 1. While the right-hand side of the equation is equal to 14 minus 1 minus root 11 all squared. Negative 1 minus root 11 all squared is equal to 12 minus 2 root 11. 14 minus 12 minus 2 root 11 is equal to 2 times root 11 plus 1. So, x equals 1 minus root 11 is a solution of the original equation. The equation has two real solutions.